Imagine this. It's the morning of June 30th, 1908. You're in a super remote part of Siberia, and suddenly the sky just explodes with the force of 1,000 atomic bombs. But here's the crazy part. When scientists finally get there, there's no crater, no fragments, no smoking gun. So let's get into it, because the story of what happened that day is one of the greatest cosmic detective stories of all time.
And look, this wasn't some abstract, far-off event. It was real, and it was terrifying. Just try to put yourself in his shoes. You're sitting there, 65 kilometers, that's about 40 miles away, and a wave of heat hits you so hard it feels like your clothes are literally on fire. This eyewitness account, it just grounds the whole cosmic mystery in a moment of pure human terror.
To really wrap your head around the sheer scale of this thing, you gotta look at the numbers. We're talking about an energy release of about 15 megatons. To put that into perspective, that is 1,000 times more powerful than the atomic bomb dropped on Hiroshima. This was a force of nature on a level that modern humans had never, ever seen before.
And that brings us to the biggest, most baffling question of all. An explosion that massive should have left a gigantic scar on the Earth, a huge impact crater. But when the investigators finally trudged their way out to the site, there was nothing. Just nothing. This one single confounding fact is what turned the Tunguska event from a catastrophe into a scientific mystery that would last for a century.
So, let's really unpack what happened that morning. Around 7:15 a.m., a fireball, which witnesses said was as bright as a second sun, streaked across the Siberian sky. Then it just detonated, high up in the atmosphere. The shockwave it unleashed flattened an estimated 80 million trees over more than 2,000 square kilometers. That's an area almost 3 times the size of New York City, wiped clean in an instant.
Now, the investigation itself is a whole other story. You'd think scientists would be all over this, right? Well, because the location was so incredibly remote, and because Russia was going through some major political turmoil, the mystery was just left to, well, fester for nearly 20 years, and that void was filled with all sorts of myths and wild speculation.
And this timeline really shows you the problem. Look at that gap. 19 years between the explosion and the first real scientific expedition led by a guy named Leonid Kulik. You had World War I, the Russian Revolution. Basically, one of the biggest scientific events of the 20th century was completely ignored as it happened. So when Kulik finally got there, he was expecting to find this giant meteorite. But instead, he just found more questions.
So, the real story is in what Kulik and the scientists after him did find. And the evidence was just weird. The trees that were knocked down, they were in a distinct butterfly shape, not a circle like you'd expect. And get this, right at the very center, the epicenter, trees were still standing, but they were totally stripped of their branches. They looked like a forest of telephone poles. Then, in the soil, they found these tiny glass spheres and unusually high levels of iridium, which is an element that's pretty rare on Earth, but super common in asteroids. All these clues were pointing away from a simple crash landing.
So, with all this strange evidence piling up, the scientific community basically split into 2 camps. There was this huge debate. I mean, if there was no crater and no big fragments, what in the world could have caused that much destruction? 2 main suspects emerged, and it kicked off a scientific rivalry that lasted for decades.
Okay, so on one side, you had Team Comet. The idea was that a dirty snowball made of ice and dust came in, and it would just completely vaporize in the atmosphere. That would perfectly explain the missing crater, right? And it would also explain the strange glowing nights people saw over Europe for days afterward. But then you had Team Asteroid. They argued that a stony object, maybe 50 to 80 meters across, would explain the chemical traces they found, like that iridium in the soil. For years and years, the evidence was split right down the middle. And then in 2013, everything changed. The case was finally cracked. The scientific jury reached a verdict, not because of some new evidence dug up in Siberia, but because something very, very similar, though smaller, happened again. And this time, it was caught on thousands of cameras.
And this is the solution, the key to the whole mystery, an airburst. So what is that? It's when a space rock is coming in so fast, we're talking hypersonic speeds, that the atmosphere itself just crushes it. The pressure is so immense, it literally vaporizes the object in a catastrophic explosion miles above the ground. All its energy gets released as heat, light, and a massive shockwave. No impact, no crater. Mystery solved.
The Chelyabinsk meteor in 2013 was our modern mirror for Tunguska. It was a smaller rock, and it blew up much higher in the sky, but it acted in the exact same way. It was an airburst that shattered windows all over the city and injured 1,500 people from its shockwave alone. By studying Chelyabinsk, scientists could finally run the models and say with confidence what a much bigger airburst, like Tunguska, would do. And yeah, the evidence pointed overwhelmingly to a stony asteroid.
So, solving this 100-year-old mystery is cool and all, but it's way more than just a history lesson. It's a profound warning. Tunguska proved that these city-killer impacts, they're not just some dinosaur extinction theory. They actually happen on human timescales. And that realization kickstarted the entire field we now call planetary defense.
Today, the lesson from Tunguska is being taken very, very seriously. As of 2026, space agencies like NASA are actively tracking over 36,000 asteroids that come close to Earth's orbit. We are scanning the skies every single night, trying to catalog anything and everything that could pose a threat to our planet.
And we're not just watching anymore. We've actually started building a shield. We have global networks that scan the skies, we've got international coordination through the UN, and this is the incredible part. We have now proven that we can deflect an asteroid. In 2022, NASA's DART mission literally slammed a spacecraft into an asteroid millions of miles away and changed its path. Think about that. An asteroid impact is the only major natural disaster that we as a species now have the technology to actually prevent.
So why all the fuss? I mean, how often do these things actually happen? Well, the numbers are a little sobering. A Chelyabinsk-level event, something that can cause injuries and damage, that could happen every 10 to 100 years. And a Tunguska-level event, something that could wipe a city off the map, the statistics say that happens every 500 to 2,000 years. In the grand scheme of things, that's really not a question of if, it's a question of when. And that leaves us with this one last chilling thought. If the Tunguska object had entered our atmosphere just 4 hours later, the Earth's rotation would have put St. Petersburg, a major European capital, directly in its path. The mystery of 1908 has been solved, but its warning is still echoing into our future. The question is no longer what happened back then, but are we truly ready for what will happen next?